Okay, in this video we're going to look at graphs of polynomial functions, and we're going to start with what's called the end behavior of polynomial functions. And we've kind of just honed in on those x-intercepts or the zeros of the function. So now what we're going to do is take a more global view and take a look at the whole picture. But we're going to start with end behavior. Let's just dive right in here. So yeah, what math concept is this? Take a good look. Polynomial. Good one, right? Maybe not. Okay. Let's get on to some serious business here, folks. So if we have a polynomial function that looks like a smooth curve as we see here, we're going to notice some things about the end behavior. And what it refers to is the description of the graph at its ends. So right here and right here. And the left side is falling, so if we were going to describe what was going on, we would say the right side is rising. Now we're going to be using a little bit more mathematical notation for that. We're going to say as x goes to positive infinity. In other words, as x goes to the right, because that's the direction of positive infinity, the graph is going up. Okay? And so you would say it's going to positive infinity itself. Again, if I were to draw on here, I would show the direction that that's going is positive infinity. And the next part is x goes to negative infinity. In other words, as you travel this way, the graph is going down. So you can think of this as west, and the graph is going south. We don't use those terms, though. We say that this side of the graph is going down towards negative infinity. Okay? And remember, the y value measures the height of the graph, so that's where the f of x comes in. Alright, so let's take a look at another graph. And in this case, we have the opposite in behavior is going down on both sides. So again, the left side is going down, and the right side is going down. So in mathematical terms, we would say as x goes to positive infinity, in other words, as it goes to the right, the graph is going down, which is indicative of negative infinity. And as x goes to the left, or towards negative infinity, the graph is going to negative infinity. Alright, so this is some of the notes that I passed out in class. They look like this. And we're going to take a look at even degree functions first. They have the same end behavior. In other words, both sides will be doing the same thing. Both sides are going up, and both sides are going down. So any even degree function will have these characteristics. And what I mean by even degree, I'm talking about the highest degree of the polynomial. If it's an even number or an odd number, that's how we determined its end behavior. Okay? If the leading coefficient is positive, then both ends are going up. If it's negative, then both sides are going down. So think of a parabola. We studied parabolas earlier on this year. If the leading coefficient is positive, both sides are going up. If the leading coefficient is negative, oops, I'll just draw another one, is negative, both sides are going down. Okay? The only difference between this and its counterparts, its even degree counterparts, is that quadratic equations are the most primitive even functions. So they are a little bit more sophisticated, so we see a lot of activity going on in the middle. And this is a higher degree polynomial function, but it is even because the end behavior is doing the same thing. Alright, so let's take a look at odd degree. And again, you'll notice that we have the leading coefficient is greater than 0 and less than 0. And we have a couple graphs under there. Let's take a look. So odd degree equations have opposite end behavior. So if we look at this, the left side's going down and the right side's going up. That's opposite. In like manner, the left side's going up and the right side's going down. So again, we can think of the line, a line with a positive slope rises to the right, and a slope that's negative falls to the right. Alright, so if the leading coefficient is positive, then the right side of the graph is going up and the left side is going down. Okay, again, very similar to the line, because the line is an odd degree function. It's a first degree function, so it is the most basic of all. There's not going to be any activity in the middle, it's just going to be a straight line. Its counterparts that have a higher odd degree, you'll have a little bit of busyness going on in the middle, like this. More hills and valleys. But the same thing is going on with this as it does a line. A line that rises to the right is positive. Okay, so in like manner, if the graph is going, if the leading coefficient is negative, then it's doing just the opposite. Like a line graph with a slope that's negative. A line that slope is negative rises to the left and falls to the right. Well, so do all of the odd degree counterparts do the same thing. We just have a little bit more activity going on in the middle. So it could look like that. At any rate, that's end behavior. And in the next lesson we'll go over some examples. So hopefully this was helpful to you.